Okay, so up until now, what you've been working with is normal frequency table. You've been working with discrete data, so numbers which had to be generally integers, fixed whole numbers. You couldn't have just any value. So we're thinking things like number of sweets, number of cars, number of people, things like that. And most of you collected discrete data, or at least turned your data into discrete data when you were making your frequency tables. So here I've got an example. This is an example like the one that I gave for when you were doing your task. So I went and asked 30 students at random to pick their favourite integer between 1 and 50, and then wrote down the results below. And from this we could draw a normal frequency table. So just like you've been doing before, with the values on the left hand side, and then the frequency that those values were given on the right hand side. So that's a normal frequency table. You can include a tally in it as well if you've got lots and lots of data and you want to tally how many times, for example, a 6 was shown or a 6 was chosen, and then you put the value next to that tally. That's a normal frequency table. But then we need to deal with our continuous data, data that could be any value at all. Now, chances are when you collect this data, it's unlikely that you're going to be given the same value more than twice. So if you were to draw a normal frequency table, it would end up looking quite messy and you'd have lots and lots and lots of rows in that frequency table. So let's take the example of height in centimetres. So say I go out and collect height in centimetres, and these are the values that I get here. Now, there aren't, as far as I can see, any repeated values in this. So I'd have to have all of those as individual lines in my frequency table. Or I can put these into a grouped frequency table. And that's going to make my life a lot easier. But you need to be careful when you're doing it. So we're going to look at a method for doing this. Now, this is your homework for this week. So it spans across quite a few pages and several exercises. You've got the full week to do it in, okay? So it's up to you how you do this. As we go through, I'm going to say which part of the lesson links in best with each section of the homework. If you want to do a part of the lesson, then do the homework that links to that, then carry on with the lesson, that's fine. If you'd rather listen to the whole lesson and then go back and do the homework, again, completely up to you how you do this, okay? Okay, so we are talking about continuous data here, okay? Or very, very varied discrete data. Say you're collecting in your discrete data, but you haven't got any values that are the same. For this, we use a grouped frequency table. So here are those heights again that we were talking about. And the first thing I'm going to do is identify my lowest value. So I'm going to put that in the table in yellow. The smallest person was 123.4 centimetres. So that is going to tell me the lowest boundary in my grouped frequency table. Next, I'm going to look for the highest value. Let's see what that is, 187 centimetres. So I know that that's going to be the highest value in my grouped frequency table. And I'm going to use these to select my start and end point. So I'll probably go for a nice round number, 120 to start with, 190 at the end. And then select a reasonable size for each group. So in this case, I'm going to split it into groups of 10 centimetres. So I'm going to group together people with heights that are within the same 10 centimetres. So let's have a look at what that looks like. Here it is here. We have starting at 120, going up to 190 up here, and they're in groups of 10 centimetres. So from 120 to 130. Now, I've used h here to represent height. Okay, that's quite important because it then makes filling in this column here much easier. I don't have to keep writing the word height because I can use h to represent it. So you're making your life a bit quicker there. And then pay attention to how this part here is written. We have this less than or equal to, and then, greater than or equal to, and then less than here. So what we're saying here is that the height of people in this group is greater than or equal to 120 centimetres and less than 130. So we would not include people who have a height of 130 in this group. That means we only have one person in this group. The next group has two people, 130 up to but not including 140 centimetres. Well, this person here is included because they're 139.9. But anyone who was 140 centimetres would not be included in this group. They would go into this next one, where height is greater than or equal to 140 centimetres. Okay, so if you want to do your homework as we're going through, this is the point to pause the video and try page 49, exercise 2C, to organise data into a grouped frequency table. The next thing we're going to do is calculate the upper and lower boundaries, and this is going to become more and more useful as we continue working with frequency. They're really easy to calculate, super straightforward. So these are called classes. Each of these is a class. The upper boundary of a class is the mean of its upper boundary with the lower boundary of the next class. So to calculate in this case, I'd need to do 130 plus 130 divided by 2. That tells me that the upper boundary of this class is 130. Obviously, for all of these, the upper boundary is going to be what's written in this part here, because this bit and this bit are the same. This and this are the same, this and this are the same, this and this are the same, and so on. So if you take a mean of two numbers which are the same, you get that number. However, it becomes more important when you have tables like this. So here, the upper boundary of this class and the lower boundary of this class are not the same. So in this case, the upper boundary of this first class is 15 plus 16 divided by 2, and that gives us 15.5. So that's when it's important to be careful with your upper boundary if the upper boundary of the first class and the lower boundary of the second class are different. And obviously you'd go on and calculate the upper boundaries of all of your classes until you get to the end here where the upper boundary is just this number, because there's nothing to average it with. Okay, so again, if you're doing your homework as you go through, this is the point to pause the video and try page 51, exercise 2D, calculating lower and upper boundaries with group frequency tables. Okay, and now we're on to our mean, median, mode and range with grouped frequencies. So we've done this with with normal frequency tables before. Now we need to look at it with grouped frequency tables, and it is a little bit different. The main difference is, for the most part, we're having to estimate what the actual heights are. So first thing that we're going to see here is that we have one student in this class. All that tells us is we have one student who had a height somewhere between 120 centimetres and 129.9999 recurring forever and ever. We don't know how tall that student actually is. So we have to estimate their height. So that makes the mean, median, mode and range a little bit more tricky to calculate. So instead of using the mode, we now use what we call the modal class. So have a think, what do you think modal class would mean? We know what the class is, the class of these here. So which one's the modal class? If you said the 170 to 180 centimetres, you'd be absolutely correct, because that has the most number of students in it. So in this case, the modal class is a height of greater than or equal to 170 centimetres, but less than 180 centimetres. So mode is fairly easy still, fairly straightforward. The median, we still need to do this median location. So we total up our frequency. And here I have 32 individuals in total. And then we have to add 1 and divide by 2 to find our median location. So 32 plus 1, 33, divide it by 2 gives us 16.5. So I'd go through, and here it's actually more useful to have a cumulative frequency table. You can add the cumulative frequency column on the end here. If you're not sure how to do that, that's something that we will go through in the next lesson. Okay, so this is when cumulative frequency tables are really useful. But we're trying to find position 16.5. So let's count how many students I've got. I've got 1, 2, 3, 4, 5, 6, 7, 14 in here. So my 16.5th student must be in this class here. Okay, so in this case, the median class, or the median height, is between 160 and 170 centimetres. Now, when it comes to calculating the mean, it gets super complicated. Because, again, we don't know the heights of these individual students. All we know is that we have 1 student that fits into this class somewhere and 2 students that fit into this class somewhere. So we estimate using something called the midpoint. The midpoint is the number exactly in the middle of that class. Then what we do is multiply the frequency by that midpoint. So in this case, 1 times 125 gives us 125. Okay, so we're saying that we have 125 centimetres worth of student in this class here. When we get down to the next one, we've got 270 centimetres worth of students in this class, and so on and so on and so on. And eventually we add them all together and we estimate that we have measured around about 4,820 centimetres of student in total. Again, I've added up all my students here and I've got my 30 students. So what I need to do now is the mean. So 4,820, the total centimetres that I measured, divided by 30, and that gives me 160.7. Okay, so 160.7 is the mean height. Okay, so what you need to do now is pause the video and try pages 57 to 58, exercise 2G with the exam style questions at the end, and page 60, exercise 2H, both of which will give you practice with the mean, median, mode and range with frequency tables, regular ones, and grouped frequency tables as well.